Part 5, the estrogen hypothesis. And so we know from science that a hypothesis must be based on observations and make a testable, reproducible prediction about reality in a process beginning with an educated guess or thought for further investigation. My hypothesis is estrogen is the precise element within the host environment which facilitates Tinea Versicolor infections. The first question, obviously, when you try to make a hypothesis is just to make sure that has this been hypothesized before? Now, I'm not the only person that's ever said Tinea Versicolor is an estrogenic issue, am I? Well, we know Ray did say that fungi use estrogen, but within this research, I've not been able to pinpoint how. It's not easily found. That information is not accessible. You type in estrogen and malassezia in the National Library of Medicine and just type in the title, you'll see nothing. Type in estrogen and Tinea Versicolor, you'll see nothing. Additionally, estradiol, malassezia, estradiol, Tinea Versicolor, just something that stands out as a title and you won't find anything. It's just something that I wrote about on my Substack that if you go even further through the rabbit hole, 1,200 research papers on National Library of Medicine mention the word Tinea Versicolor, 1,602 mentioning pityriasis versicolor. In over 2,800 articles, the word estrogen only appears once. So if you look at the malassezia yeast centrally involved in Tinea Versicolor, there are 3,202 peer-reviewed articles mentioning the word malassezia. And of these, only 4 articles actually mention the word. You can go to the National Library of Medicine. I've even left links to these searches on my Substack. And so this essentially means, based on the metrics, that there's a 0.1% chance that the experts will discover the root cause of the condition. Estrogen, we know, occurs in both sexes. It is a hormone that is found in the skin. There should be a hypothesis made. So what's going on here? I asked ChatGPT on March 12, 2025, was there a relationship between Tinea Versicolor and estrogen? And it responded, yes, there may be an indirect relationship between Tinea Versicolor and estrogen, though it's not fully understood. And so when you go through the framework, you will continuously see this. It's not fully understood, poorly understood mechanisms. And they will build everything on top of that statement, as if it's to be assumed that it can't be understood. You read further down, it says, however, it's important to note that the relationship is not straightforward and more research is needed. Well, we're here to do some of that research. What evidence do we have to support the hypothesis that estrogen is the missing element within the host that triggers TB infections? So for one, we know vaginal yeast infections occur during menstrual cycles. Menstrual cycles display dynamic estrogen to progesterone ratios. At certain points in the cycle, estrogen is elevated relative to progesterone, and estrogen and progesterone ratios can be measured and determined by measuring the blood in the urine. Here at the bottom, I mentioned that the ratio must be emphasized. The ratio is super important to understand, and we'll talk about that more in a bit. So here's one scientist's interpretation of estrogen and progesterone during women's ovulation. This is et al. 2018. And so you can see between day 10 to 14, estrogen is really in a dominant state while progesterone stays subdued. And it is until after the 14th that you see an increase of progesterone to try to catch up with the elevated estrogen. And so there are windows of time where estrogen is far more dominant than progesterone during the cycle. Here's another interpretation of the menstrual cycle. And again, estrogen tends to rise between day 7 and day 16. And the subsequent rise of progesterone usually takes place between 14 and 21. So there's a discrepancy in these two substances. And in that window, when estrogen remains elevated while progesterone stays down, that is a very vulnerable state for a woman. What I'm suggesting is that it is a very vulnerable state for any cell. We have another hypothesis. Vaginal yeast infections are a side effect of birth control. It's usually in the estrogen, or sometimes now they're using estrogen and progestins, and those alter the natural estrogen to progesterone ratio. And estrogen and progesterone is also measured in the blood and urine in these cases. So there's a part two to this part of the hypothesis. The main yeast that is involved in vaginal yeast infections are the Candida albicans. Candida is considered a relative of Malassezia yeast, and Candida is known to have an estrogen receptor. So let's just look at that estrogen receptor really fast. 1989, this is Skoronsky, and they say characterization of an estrogen binding protein in the yeast Candida albicans. An estrogen-binding protein has been identified and characterized in the cytosol of the pathogenic yeast Candida albicans. And if we just scroll down, we don't have to read the entire thing. They say binding competitions experiments showed very high specificity to the stereoselectivity of estrogen-binding protein, demonstrating the following order of potency in displacing estradiol, beta estradiol greater than estrone, greater than estriol, greater 17 estradiol. We could go a little bit further into this study. Just wanted to highlight a little bit more things that are important for future commentary that is welcome. Criticism and commentary is welcome. They say no competitive potency was found for diethyl visceral DES, a potent estrogen in mammalian systems, or for the estrogen antagonist tamoxifen. The other compounds representing these classes of steroids, including progesterone, testosterone, dexamethasone, corticosterone, and aldosterone, had minimal or no competitive activity versus estradiol at the concentration tested up to 1,000-fold molar ratio. So this paragraph is saying that Candida albicans has a very selective estrogen binding protein that only reacts to a specific estrogen compound, the estradiol, estrone, estriol, and 17A estradiol. Unlike human estrogen receptors, this fungal protein does not respond to DES, a synthetic estrogen, or tamoxifen, a drug that blocks estrogen in humans. It also does not bind to other types of steroid hormones or other fungal hormones with estrogen-like activity. So they're saying this is a very exclusive phenomenon that's taking place, and it's taking place only with the natural estrogens that are made by the body. I wanted to make sure I put this out there, and I do invite the criticism and the commentary. I'm not talking about DES. I'm not talking about the man-made estrogens. I'm talking about natural estrogens that are made in the body when I'm saying that, yeah, perhaps the Malassezia yeast are binding to the estrogen proteins. Do the Malassezia yeast have an estrogen binding protein? Okay, that would be the obvious question to ask. Since the Candida yeast have an estrogen binding protein, a 5-year-old would ask, do their relative yeast have that estrogen binding protein? And once again, you can look throughout all of the databases and the internet and you let me know what you find, because I haven't been able to find a Malassezia related estrogen binding protein. Obviously, I wouldn't have to do this as a long video and you'd be able to solve your skin. The last one, which is really where things get very interesting, is that yeast infections occur during menopause. Many women report onset of Tinea Versicolor during perimenopause, that transitional phase. Menopause is considered an estrogen deficiency, and estrogen deficiency is measured in the blood and urine. So estrogen deficiency is seen in aging women as the missing key to chronic TB. This is the hypothesis that I propose, and I'm going to show you here in these 5 categories how this phenomenon takes place and how it can be tangibly seen as so. So the first one is the estrogen deficiency in the blood and urine does not mean estrogen deficiency in the skin. In fact, missing estrogen can be explained as leaking out from the blood and the progressive accumulation of estrogen into surrounding tissues. Breast cancer is acknowledged as having 9 to 15 times as much estrogen in the adipose tissues of breast compared to normal blood levels. So this is a perfect example that estrogen does leak out from the blood into other tissues, as seen in breast cancer. The adipose tissues are a major producer of estrogen. And of course, estrogen can convert other cells into estrogen via aromatase. And so if you just look into Google and you type estrogen produced in the skin, and of course, you're going to get it. Yes, skin cells can produce estrogen through a process called aromatization, where androgens are converted to estrogens by the enzyme aromatase. And so here's a quote by Ray. He says, the concentration of a hormone in the blood doesn't directly represent the concentration in the various organs. Okay, so sometimes blood work is not going to answer the equation. Here is a study that was taking place in 2022, steroid dynamics in the normal and carcinomatous mammary gland. This is just highlighting the estrogen deficiency. And so just here in the conclusion, we don't have to go through the entire article. It says, in both normal and carcinomatous breast tissue, concentrations of E1, estrogen 1, and E2 are significantly higher than in plasma, suggesting either uptake or local synthesis. As to the latter, aromatase activity accounts probably only for a minor fraction of the tissue estrogens. So where's that estrogen coming from? Hello, everyone. So in the last video, we ended off in the question asking, where is that estrogen coming from that's accumulating in the tissues? Here in this estrogen deficiency situation, you'll consistently see the word uptake. Normal and carcinomatous breast tissue concentrations of E1 and E2 are significantly higher in the plasma, suggesting either uptake or local synthesis. And so if local synthesis is only amounting to a fraction, then obviously the majority of the estrogen that's accumulating in the tissues via the bloodstream, where you can normally measure the estrogen, it's almost obvious. And many researchers are alluding to this fact. So here's a study here. It's called Local Uptake and Synthesis of Oestrogen in Normal and Malignant Postmenopausal Breast Tissues. And I'll read it to you. Estrogens influence the development of both the normal breast and breast cancers. However, in postmenopausal women in whom most breast cancers are diagnosed, local levels of estrogens in the breast do not simply reflect those in the blood. Thus, after the menopause, when estrogens in circulation fall, levels in the breast do not change significantly, and as a consequence, their concentrations in the breast may be more than those in the blood. This can only occur as a result of an active process, selective sequestration of estrogens from the blood or local formation by breast tissue itself. Both these mechanisms have been shown to occur. And so I just have that word sequester here defined for you. It says to hold in solution, especially for the purpose of suppressing an undesired chemical or biological activity. So the tissues are, in a sense, storing that estrogen to suppress some of the responses that estrogen induces. This is a safety mechanism. And what are some of those responses that estrogen produces? We will cover that more towards the end of this video. But this is, in a sense, a survival mechanism that is taking place. We can talk about breast cancer next. This was by Geisler in 2003, and they say plasma estradiol E2 levels decrease at menopause by about 90%, and one could expect that breast tissue E2 levels would decrease simultaneously. However, several investigators have confirmed that breast tissue E2 levels are maintained at nearly the same level as seen in premenopausal women. Thus, breast cancer tissue E2 levels are about 10 to 20-fold higher, and breast tissue estrone is about 2 to 10-fold higher than their corresponding plasma levels. This observation may be explained by local synthesis and or estrogen uptake from the circulation, as well as altered estrogen metabolism. ¿Me puede dar un chance? Gracias. Gracias. Okay, so again, all of these researchers are pointing to the same thing. They're all saying in different ways that estrogen is being uptaken from the blood into the tissues. We can talk about adipose tissue, where the estrogen then becomes stored. This is a study in 2021. It says adipose tissue estrogen production and metabolism in premenopausal women. We'll just read the design and methods. Serum and subcutaneous and visceral adipose tissue homogenase from 28 premenopausal women undergoing non-malignant surgery were analyzed for estrone, estradiol, and serum estrone sulfate, and we'll just go down to the results. You can read through it on your own time if you'd like to. Median levels of estrone were 5 to 10 times higher in subcutaneous and visceral adipose tissue than in the serum, and the estradiol level in visceral adipose tissues was 1.3 higher than those in the serum. And this is premenopausal women. We'll just look at some of these images here. These are gathered from different places on the internet, different studies that I've seen. So here's just one person's interpretation of where some of the adipose tissue is known to accumulate. And so here you have it in the brain, you have it on the upper body, in the torso area, the stomach, the legs, gluteal Zoom in here to the left. It's like a man here. He's got brown adipose tissue up top near the abdominal and the arms, the glutes, the femoral. And if you look into the blood vessels on this circle here, you'll see how easy it is to now interpret the idea that estrogen is being taken out of the blood and being uptaken into the adipose tissues. You can see how near the tissues are to the actual vessels. It becomes very apparent that, of course, there's likely some kind of spillover. Essentially, being able to intervene in this spillover would be a therapeutic approach. And so here's some images of myself, and as you can see where my infection was, up top where the adipose tissues are, here down by the arms. I have had it on the stomach as well. I have clients who I'm working with that have it on their stomach. It's a very challenging area to get rid of. Many people report it on their backs. These are the areas where the Malassezia yeast are in fact accumulating, and this is also where estrogen tends to accumulate. And then we can talk about the last bullet, which is the aromatase enzyme. So here in this article, aromatase in aging women, cessation of ovarian estrogen secretion is the key event during the climacteric. Aromatase expression in adipose tissue and possibly the skin primarily accounts for the extragrandular peripheral formation of estrogen and increases as a function of body weight and advancing age. Here it says sufficient circulating levels of biologically active estrogen, estradiol, can be produced as a result of extragranular aromatization of androstenedione to estrone, which is subsequently reduced to estradiol in peripheral tissues to cause uterine bleeding and endometrial hyperplasia and cancer in obese, anovulatory, or postmenopausal women. So this is a very interesting sentence that I ended up bringing into ChatGPT because it's worded so elusively, and here you're going to really see the issue that's taking place here. Because why would you want to do that? Why would you want to have sufficient circulating levels of biologically active estrogen to be produced? So I brought this sentence into ChatGPT and I asked it, explain this logic. It says, this sentence explains how obese or non-ovulating postmenopausal women can still have high levels of active estrogen despite not producing much estrogen from their ovaries. And then I asked them, it's interesting how they do not mention progesterone in the text though. And it says, exactly. And that omission is very telling. The entire pathological chain described in the sentence hinges on unopposed estrogen, and the word progesterone should be central to that discussion, yet it is missing. Here's why that matters. What's being implied but not stated, progesterone's job is to counterbalance estrogen's effect on the endometrium. It regulates cell growth, promotes shedding, prevents hyperplasia. Without it, which is common in anovulatory or postmenopausal women, estradiol stimulates unchecked growth. So the sentence outlines the mechanism for how estrogen gets there, but it ignores the crucial fact that progesterone is absent, which is why that estrogen becomes harmful in the first place. And then it says why this matters. This kind of omission is common in literature and has consequences. It oversizes estrogen as the culprit. It ignores progesterone deficiency as a major variable. It subtly reinforces treatment models focused on estrogen suppression rather than restoring hormonal balance. This logic, in short, is technically accurate, but the framework is biased by omission. Leaving out progesterone leaves out the core of the problem. So this is the issue here that's perfectly worded by ChatGPT, which says that there is bias based by omission. This is the problem that a lot of people with Tinea Versicolor are dealing with too. And so I've done all of this, these 5 bullets, just to really hint and point out the fact that if the Malassezia yeasts are binding to estrogen similar to how the relative Candida yeasts are, then it could be argued that chronic TV is a display of estrogen dominance within the skin and the adipose tissues.